All right, 9-1.
Oh.
Why did you take it
How
back?
many shots do
Okay.
you think we're gonna get to, like 10?
Yes.
Probably only have one more test, right?
Yep. 9. We're doing 3 sections in 9 of the 4, and then we're doing a couple in 10, and then we're done. So.
I don't really care.
Senior citizen, you wait till you're excited, but also keep in mind, that makes you more different than being an adult.
Yeah, that's why I know.
No, right now she feels like, oh, happy because she's gonna be a senior, and then a year from today, she's gonna be crying.
She's gonna be like crying, and my mom said, you need to start looking around for senior pictures, and I started crying.
Okay, we're going to be looking at correlation between two variables, seeing if a correlation even exists, what kind of correlation it is, and how strong is that correlation. So we're just going to look at some common sense right now. What kind of correlation do you think exists between height and IQ score?
Zero.
Nothing.
Probably no correlation. Are taller people smarter than shorter people?
No, shorter
Dumber than shorter people? We're probably
Everybody forgets about
guessing.
the average height depends on.
So we are probably guessing no correlation here.
Well, if we correlate between Holly and
The
I.
taller you are, the less blood goes to your brain.
That's what I just said,
Lucas. Oh, you said taller people. Maybe you should. What?
Maybe average height is the dumbest.
Okay, how about hours of sleep? And I've got reaction time.
That's definitely correlated.
I was gonna say, Keeker doesn't care about those.
Actually, I really don't know.
So-
Sometimes when I have little sleep, I just am like,
What do you think? Do you think there's a correlation here?
well, somehow.
More sleep, faster reaction time. We think that a relationship exists. How strong is it? I don't know until we do a study. So we do think there is a, how would you call that correlate? What would you call it? Remember back from algebra, the positive or negative? Because we're doing linear correlation. So you think more hours of sleep,
Less reaction time.
quicker reaction time. So that would that look like on the,
No,
let's see,
you're getting
more hours of we do
your
sleep
fast
here,
reaction.
fast reaction time, less hours of sleep high. So it's going to be a negative.
Yeah.
See it?
Yeah.
Let's see. If we do hours here, reaction time here, so if we've got a lot of sleep, we would expect a real fast reaction time.
It's not pertaining to.
Less sleep,
No, it's not.
slow high reaction time. So that's going to be a negative relationship. Do you see that? Just guessing. So we're thinking a negative relationship.
I don't think you got enough sleep.
So, we will be focusing just on linear, but all relationships or correlations linear? No. So we've got our independent variable, which statistics calls the explanatory variable. And then we've got our dependent variable on the y-axis. That's from Algebra 1. Independent and dependent from algebra, I should say. And statistics calls the dependent variable the response variable. And if we have our scatter plot looking like this, it's slightly negative. Linear correlation.
Oh, it actually, oh, whoops.
So as the independent variable increases, the dependent variable decreases. That's a negative. Our positive will look like that. And not everything has to be linear. We are only going to be focusing on linear, but you might get something that looks like,
Exponential.
or,
Not exponential.
what did I go for there? Quadratic.
Actually, a parabola.
Parabola. So, and it could be exponential. There's all kinds of non-linear. But we are only going to be doing linear ones. This is just so you know they exist. And then we've got the no correlation like we had up with the height and IQ score, where everything's just all over the place. Good?
Connect the dots.
Yeah. No correlation.
Constellation.
We are going to be focusing on one example all the way through this section, so we're going to make a little scatter plot of it. And I'm going to ask you first, the scatter plot is going to be the amount of income you have and the percent of your income that you donate. What is common sense going to say to you about that? What your income level is and the percent that you donate to charities.
Donate to charity.
What do you think is going to happen here?
The more money you
The only
make, the more
charity I'd put
you're willing
money
to donate
into.
to charity.
Okay, Taylor's guessing positive. She's saying the more money you make, the more money you're going to give to charity. See what the scatter plot, see what the sample data tells us.
Providing the money that somebody made.
So, what type of correlation?
What type of horrible human being that?
I like shooting.
That's our question. This is right there. So we're going to make a scatter plot. I'm going to give you the table because we're going to, like I said, we're going to be using it through the whole thing. Our income level, and this is in thousands of dollars. And then the donating percent. And they did a sample of 1, 2, 3, 4, 5, 6. Okay, the first person, income level was $42,000, donate 9%. $48,000, donate 10%. $50,000, donate 8%. $59,000, donate 5%.
Assume too much from you.
$65,000, donate 6%. $72,000, donate 3%. This is percent. So 3% of their income, 6% of their income, 5%. Okay? So, let's make a little scatter plot. Okay, so our income is our dependent or explanatory variable. These are thousands of dollars. And then we've got our donating percentage. Okay, but because our first income's starting at $42,000, we'll put a little break in there. And we're going from, let's go by 10,000. Or do we have enough for 5? 40, 45, 50. Let's go by 5. 55, 60, 65, 70. Fit that in. Make it fit. And then here we only got to go up to 10, and we're starting lowest is 3, so we'll count by ones there. So will you make a quick scatter plot? I'll make my scatter plot. Okay, so what kind of relationship do you see? Definitely negative, and that is true data. The more people make, the less percent they will donate. Yep. Percent.
This is assuming that the people with the lower income are actually donating to charities. You're assuming people are nice.
You could figure it out, you know, just 3% of 72,000, how much are they donating?
I mean, I gave 50.
And 10% of 48,000.
They're
You can
donating
do that one. Yeah.
You think
It should be
the
the
more
other
money
way
you-
around, yeah.
The more money you make, the more willing you be to
Mhm.
donate to charity?
Yep, you would think. Doesn't work that way. The more money, the more they want to hold on to it.
I feel like,
Lori got
so
it.
too though, like, the people who make more money, they've probably been in a harder spot too, so they know how hard it is to come out. So when they're in a good spot, they probably.
Who knows what goes through their mind? Okay. So, now we're going to talk about, I don't know if you did this in advanced algebra or not, correlation coefficient, the R value, that tells you how strong the relationship is. Did you guys do that in advanced algebra?
Don't remember.
Don't remember, okay.
All that class.
So, you can
Yeah.
see if we tried to draw a line through here, or wherever, you know, your best fit line, and we used to eyeball it,
Line of best fit.
line of best fit.
Best fit line. What do you think the?
And then the closer the points are to being on that one line, the stronger the relationship. And there's a number that we give to that. It's called the correlation coefficient.
You know, to be perfectly honest, I could have told you this was negative from the beginning.
I asked, you didn't offer an answer.
Not fair.
Correlation coefficient, which we call R, lowercase r, is a value that indicates the strength and direction of the correlation. Okay? If R is equal to 1, that's a perfect correlation. Oops. Perfect correlation. Every single point lands on the line. Nothing's off the line. So R equals 1 is a perfect correlation. I should say positive or negative. Because a negative 1 would be a negative correlation, but every single point's on the line. A positive 1, positive, but every single point's on the line. So that's a perfect correlation. So I'm going to show you some examples so you can see, and they don't have the lines drawn in, but take a look. We're going to be calculating R values here in a minute, so if you kind of estimate your line through there, this one comes out because a lot of the points are kind of a little bit far away, but you can definitely see a positive correlation there. That R value came out 0.81. Okay, this one here, they do look a little closer and tighter to the line, and it's negative. It came out negative 0.92. This kind of scattered, but I do see a positive. If I kind of loop it around there, I do see a positive, but 0.45. So you can see the more spread out, the lower this number gets. And this one all over the place, where you say no correlation, the R value is almost down to 0.04. So if the R value goes from, I don't know that it would ever hit 0, but close to 0, greater than 0 to 1. All right, and we're going to be finding that R value, and it's a whole lovely formula.
Just get them away.
Oh,
That's a lot of sums.
But we have calculators with lists that will do this for us nicely. So here we go.
Yeah, but we could do that,
Yeah, but there's not a lot. Look, we're going to be doing this one here. Okay, so calculating a correlation coefficient. We want to know how strong the relationship is. So calculating the correlation coefficient R. Okay, you need 5 values. You need to find the sum of your x values. You need the sum of your y values. You need the sum of the x times y. The sum of the x squared. And the sum of the y squared. And our lists are going to do all of this for us. Okay, once you've got those 5 values, it's just a plug and tug formula to get R. And you saw it, there's a little peek at it there. To get the R value. So, you're going to take the N is the number of data points you have, times the sum of the x times y, so value 3, minus the sum of x times the sum of y. Then you're going to divide by 2 square roots down here.
Oh, God.
It's ugly.
This is turning into the not pool.
Yeah, to the pool. It is kind of like the pool. The sum of the x squared minus the sum of x
So in a calculator, are those
squared. These are not the same thing here. Notice, this is the x value squared and then add it up. This is the sum of the x's. You take that result and square it.
Can you replace the sums with lists then, technically? Is that how that's going to work?
No, we're just going to write the one with values.
Oh, there's another square root. Okay.
Yeah, I told you 2 square roots down here. And it's the same thing with the y's.
Oh.
The sum of y squared
Why can't we
minus
replace these that right way?
sum of y squared. So let's find out how strong that correlation was for the income and donating percent.
That.
So finding R for example 1. So how many lists are we going to need? Oh, only
1, 2,
3.
4, 5.
We need x, y, and then the x times y, and then we will get all the sum things. So I will do this with you so you can follow along. So get your x values in a list and your y values in a list.
We need the numbers first.
You have them, example 1.
Which one's X and which one's Y?
The income was x and the donating was y. You guys pay attention over there, get your list going. So x is in a list. And the order doesn't matter, this has to be paired up correctly. Even though these are in increasing order, that wouldn't have to happen. So I got x is going in list 1, y is going in list 2,
List 1 times list 2?
and then the third list, because we need the sum of x times y, our third list is going to be list 1 times list 2.
Sorry.
Yeah.
Do you have to put them as height 0, 9?
No.
What? Why not?
It's going to be the same thing. I mean, it'll be fine. The R value will still come out fine. That doesn't matter.
So list 4 is list 1 squared?
No.
No?
No, we want just list 1 times list 2, enter. Okay, are we ready?
Yep.
Let's write down our 5 things here. We want the sum of x, the sum of y, the sum of x times y, the sum of x squared, and the sum of y squared. Okay.
This is going to get so tedious.
All right, we're going to quit and get out of here. Run 1 var stat on list 1. So stat, calc, 1 var stats on list 1. And take a look. Does it add up the x's for me? What is
And
it?
X squared.
And the x squared. So we get two of our values off of one bar stats list 1. So 336. And if you look down a couple lines, you've got the sum of x squared. So that's 19,458. Okay. So what are we going to do next?
One bar stands for list 2.
There you go. Stat, calc, one bar stat, list 2. So the sum of x is, well, it would be the sum of y's, but, and then the sum of the squareds is 315.
Then you do it for list 3.
And then you do it for list 3.
You just need the sum.
We just need the sum, 2159. So after that, it's just plug and chug. Okay, so to get the R value, what is n again? How many data points did we have? 6. Times the sum of x, y is 2159. Minus sum of x is 336. Times 41. 6 times 19,458 minus, what are you going to put for the sum of x squared? What is the sum of x? And we're going to square it, so you're going to have 336 squared.
I can give you that right now.
Nope, I'm just writing it in like that. And then the next square root. 6 times 315 minus, and then I want the sum of y, which is 41 squared. Okay, if you're doing this correctly, you should be getting a number between 0 and 1.
Well, let me tell you.
And we know it should be coming up negative, because we already saw the relationship when we made the scatter plot.
But for the top, it doesn't matter, the order you read it.
Okay, can you take that back? Retracting that question?
Yeah.
Okay.
Yeah, good choice.
Yeah, the chance.
Yep.
Hold on, we're close.
How are you doing?
I squared root is better than
I have so many parentheses in here, I don't know how I did it. Yeah, 'cause I get scared to.
I got 9,700.
Shoot, terrible calculator user.
Yeah.
Terrible, I say.
You're telling me that's not it?
Nope.
I'm only about 9,700.
Yeah, I'll come and check that out later. I will check that out later with you. Okay, the last thing we want to do now, pretty quick.
What did we get? Oh, boy, yep, okay, that's your problem.
Chasey didn't get it.
Casey didn't get it
You
either?
just rushed
What'd you
me
get?
so that
Oh,
I tried
rush.
using all the parentheses.
What'd you get? What'd you get?
Did you get 9,000?
.00807.
I'm closer.
No, I wasn't.
you got a
In
9
my
there.
last one, I
Oh, I
started
got
out really
2.28.
whoa. I'm like, okay.
Why did you arrive?
Because you told me
I will help you. I'm gonna move on, then we'll get the last part done.
No.
No, I'm not gonna, do you have it all in there?
Yes, that's the whole line.
Let's see,
Wait, what was the answer?
how do I get back?
Just hold up.
Okay.
Okay, I can see it right now.
Ouch.
You gotta put another set of parentheses around the numerator. I'm gonna insert,
2?
yeah, because otherwise that's gonna, all it's dividing is that second one. Because you gotta need it to do the whole numerator, which includes, oh, I'm just gonna delete that, because you don't really need that anyway.
Why?
Oh,
'cause that first one came up,
Yeah.
that first one was a... Okay, so,
We're getting closer.
alright, so we got the numerator.
Hit
Alright,
enter.
Oh, jeez, see the bottom. Did you, parentheses the whole bottom? Doesn't look like it.
Yeah.
No,
Okay, I see the question.
because you got two, square roots down there.
Yeah.
Negative.
Oh.
So it's gotta multiply those, so you need something
Oh,
around the
yeah.
whole numerator and around the whole so it does that, and it does all of that.
Okay.
Let's see what we get here.
Hey guys, I did it.
Okay,
Got it.
here we go.
I'm a champ, I did it.
Last thing.
Because I said that.
I like said it royal.
Yeah.
It's only-
Try.
Got hot stuff.
No.
Michael's like ready to be like, oh, we're doing more.
Yep.
No, I still got the wrong answer, it's okay. You don't wanna check my calculator. Yes, sure, it's not 10.4.
No.
Right, yeah.
Okay, we're gonna do one more hypothesis test. I think it's our last, it says the last one for the chapter, by the
Is
way.
that a P or is that a?
That is a Greek letter rho.
It doesn't even look like an R.
Rho, because it's the population value for our R that we're using, but they call it rho. It looks like a P. But I think they're using rho because it starts with R and our correlation sample coefficient is R, so I think that's the connection there.
It looks like a fish.
So,
It reminds me of Swan.
what we're saying is if rho
Swan House would be proud.
does not equal 0,
Jesus, fish.
that means we've got a significant correlation.
This is kicker type of math.
Yeah.
This is the claim?
Yep. If the rho then equals 0, there's no significant correlation.
Call it the Swan.
No, fish hawk.
Okay, and this is all we are checking. We're only checking if they're
It's
significant.
like a swan. Yeah.
I see it.
See?
People
Like,
listening
I
to this
see it,
recording,
but I
I'm
don't-
sorry.
I have no vision for that.
It's like graceful, like swan. Except I heard swans are actually really mean.
Oh, yeah.
You've ever seen videos of them?
They're like for their own
No,
protective.
swan hot.
It's crazy.
Yeah. That's where the.
Don't get between a swan and his face, man. It will-
Okay, we could test for a strong positive correlation. That claim would be written rho is greater than 0. Or we could test for a strong negative correlation, and that would be rho less than 0. We're not doing those. So these are not.
Oh, I see. Those dashes for each thing.
Yeah.
I did not get that. I thought you were covering up half of it.
No, we are not doing that. We're only checking to see if it's a significant correlation, so this will be your claim every time. Those are dittos. Good test for a strong negative correlation. Ditto means the above.
But that's supposed to be
That
negative
shorthand notation you guys
correlation,
don't know?
Let's just move on.
You do know that, okay.
I.
Yeah, I used it yesterday.
Pika goes to
I used it to check my school, everything's running on it, like, it marks the accent.
What are you getting?
Critical value is a t-value.
Yeah.
Guys, stay with me.
Nah.
Degrees of freedom, n-2, because you've got two different variables you're working with. So t-table and degrees of freedom n-2. And once you calculate your R value to turn that into a t-score, it's a simple plug and chug.
Oh, it's a nice big one.
Nope. R divided by square root of 1 minus R squared over n-2.
Why is it n-2?
Because there's two different income level and donating percent. Each one of those different items gets a degree of freedom taken away. Okay, so we're just going to test the significance of the correlation coefficient we just found, and we will be done.
Is this gonna take a lot of room?
A regular hypothesis test.
I can fit it.
Okay, so last one.
7 lines?
That's enough work.
Test.
You went too fast, pulling that away, can you put that back for a second?
Significance,
I have a marker.
nope,
Just that last formula.
of the correlation
And look at the
Coefficient.
phone. R divided by.
in
Make your graph head.
example 2.
Oh, no, I didn't do it into account how big this is.
Test alpha equals 0.1.
Okay.
Okay, you're good.
Okay, and our R value in example 2 was negative 0.92. Okay, the claim is always the same. You can't mess these up. The claim is that there is significant. Always, all the way through. Claim is significant. Making the claim the ha.
Somebody's not in this class who had to read that would be so confused.
The ho. So they're always going to be two-tailed tests. So using your t-table with, it would be 4 degrees of freedom because we had a sample size of 6. 6 minus 2. And 0.1. Oh, so 0.1, actually this would be 0.005. Divide that 1%.
So the claim is always.
Always, yep, it says, see if there is a significant correlation. Test to see if there is a significant correlation. So what's this T on the critical? Positive and negative 4.604. And we've got our R value. We already calculated it, so now we'll turn that into a t-score. Since I'm squaring the 0.92, I'm not going to bother with the negative, because we know a negative squared is just going to go positive anyway. So I'm just not even going to bother with the negative. So I didn't even need the parentheses.
When in doubt, just slap parentheses everywhere. I'm not
You obviously didn't do that last time, did you?
I slapped them almost everywhere, I missed the spot.
You missed 2 spots, around the numerator, around the denominator.
But I put them everywhere else.
Where you didn't need them. That's good.
You see, I had them.
I had them all, I
You failed.
Oh, no.
Yeah, you're
Really, that's like the
Reject.
closest one.
Reject.
Negative 0.4.
Reject that. Oh.
I did something wrong.
Negative 4.6 what? 9?
Negative 4.69.
So reject the hoe. Claim is true, there is a significant correlation. Okay.
Page 47, 1 through 2.
Wait, what?
You can stop. No, you please stop.
There it is.
That's a lot.
It's a
Not
lot,
bad.
a lot of nothing.